Howdy everyone, and welcome to this video going over some example problems from Chapter 2. This will be the first chapter that you have a homework set for Chem 101, and I think it's useful to have some practice about the different types of mathematical problems we'll be doing throughout the course. So in this video, we'll be looking at scientific notation, measurement, some sig figs problems, and some metric conversions. Those, especially the metric conversions and dimensional analysis, we'll be doing them at various points throughout the semester. So this video might even be helpful to come back to when we get to that future stuff. So if we look forward there, oops, there we go. Let's go ahead and look at this first example problem. I will be giving you the problems, the numbers that they are in the book. So if you flip in your book or on the e-text, you go to the end of chapter problems, you'll find these. One thing I do really like about the textbook is that it's really well aligned with having an odd problem where the answer is given in the back, right next to an even problem where it's the exact same problem. All they do is change the number or change the chemical, whatever it happens to be in that chapter, but it's the same exact problem 2 times in a row. So you can practice a problem where you can see the right answer. If you get that, then you say, okay, I know I did this right. Let me try the real one for credit. All right, but for this first one with scientific notation, it says we're going to express this first number in scientific notation. That means we need to get the decimal point here after the first number, whatever number between 1 and 9. And so we're just going to count how many times do we move that decimal. So 1, 2, 3, 4, 5, 6. We're going to move it 7 times. And that's going to tell us that it's 10 to the 7th. So we write exactly what we see, 3.8802. We'll leave those zeros off because that's the point of scientific notation, to not have to write them. And then we do 10 to the 7th power. Now we know it's the positive 7th because this is a large number, bigger than 1. That means it's a positive power of 10. If it's a smaller number, if it's 0.0000 something, that's when you have 10 to a negative power. But it's always about how many times did you move that decimal. In this case, then, for 35C, we're going to take this number already in scientific and make it decimal notation. Sometimes it's called standard notation. But this means, okay, 10 to the positive 8th. That means this is a number bigger than 1. So we're going to be moving our decimal that away to keep it bigger than 1. And we're going to move it 8 times. So I'll write 2, 9, 9. That's already 2 times. I need to move it 6 more, so 6 zeros. 1, 2, 3, 4, 5, 6. And then if you wanted to put commas in, you could do that. Online for your homework, you won't ever be writing in commas, so just 299 million would call it good there. And if they do ever give you a unit, we should write that as well. It should still be meters per second. That's the speed of light. All right, so that's just a little review of scientific notation about which way you move the decimal based on the power and how many times. All right, next up, we're looking at 2.41a about measuring volumes or just measurements in general. The key thing with these, and we'll go over this in lecture if you haven't already, is that we write down all the certain digits, everything that we know for sure, plus 1 estimated, where we'll look between the lines and say, okay, what am I estimating between those lines? So for this problem here, this is more something you're going to do in lab. On the online homework, I checked the problems are multiple choice, so it's, which one has the right number of estimated? But in the lab, this is what we're doing, and you have to estimate between those lines. So I can see, okay, there's 50, there's 60, and I have tick marks. I know them for sure, right? The lines are given. So I look at the bottom of the meniscus right about there, and I say, okay, it's definitely above 50, above 51, 52, 53. It is above 54, but below 55. So for certain, I know 54. And then I'm going to estimate. And, okay, yeah, this image is blurry. I had to blow it up from the image in the book. And so it's kind of hard to see, going over. I'd say it's a little bit less than halfway, but not much. So I'll say 54.4, and then this would be milliliters. But the beauty of this last digit, it's estimated. If another person said 54.3, that's right. If another person said 54.5, that's right too. It's estimated. It's supposed to be a good estimate, so plus or minus 1 is what we usually say. But they're all, scientifically speaking, the same answer. So 54.4, but having one digit that we're estimating, that's the key for a problem like this, knowing, okay, one's more spot between those lines. All right, for our next example, we'll be looking at sig figs with multi-step. So in lecture, we talked about the rules about, okay, when you're adding and subtracting, you care about how many decimal places are significant. For multiplying and dividing, you care about how many total significant figures you have. And if you have a multi-step problem, well, you apply those same rules just one at a time, but you don't round until the very end. You carry extra digits with you just to make sure nothing funny happens, and you kind of indicate where should it have ended, and then let me apply that. So we'll do this problem here, where we have 892 divided by 986.7 in parentheses, and then plus 5.44. So we're still doing normal math, right? If we remember our please excuse my dear Aunt Sally, PEMDAS, however you learned it, we're going to do the parentheses first, which in this case is dividing, and then we'll add that. So we grab a calculator, and we go ahead and we always calculate like normal. So 892 divided by 986.7, and the calculator gives us this lovely 0.9040235. I'm going to end it there at the 5. Clearly, this is more than what we should have. But I'm just going to keep that in. And then plus 5.44 still. And then I'm going to say, okay, well, let me add this together. Let me just go ahead and add 5.44. Do my problem completely like normal. And if I do that, the answer I get is 6.344. I'll just keep the 0235, same as over here. And so this is what I will call the calculator answer. But it's not our sig fig answer. We got to figure out where should this stop. And so we got to apply our rules one at a time. Our first step was dividing, and multiplying and dividing cares about how many sig figs do we have total. So we look at the 892, there's 3 digits, none of them are 0. They're all significant, so that's 3 sig figs. The second number, 986.7, well, again, they're all not 0, so they all count. That's 4 sig figs. That means in our answer, we go with the fewest, and the fewest is 3. So we're allowed to have 3 sig figs here. And so now we got to look, well, where are those 3? This 0 is a leading 0. Those don't count. Zeros only count if they come after some other stuff. So that 0 is not good. But the 9, the 0, and the 4, those 3 count. They're my 3 sig figs. And so I underlined them here so I know they're significant. Sometimes you might see in the book as an example, they'll put a bar over that last digit, like that 4 there. Whichever way is fine, just indicate this is what's significant. All right. Now when I go to add it, okay, the adding and subtracting is the other rule. That cares about how many decimal places do I have. So there I compare. The 904 goes to 3 decimal places. The 5.44 only goes to 2. Well, that means the answer can only go to 2 decimal places. So when I come to my answer, I'll say, okay, 6.2 decimals, 3, 4, and I'm going to stop my answer right there. I'll then check for rounding. I have a 4 that comes next, that rounds down, and that means the sig fig answer should be 6.34. And so that's how you would do this problem. But always, again, just kind of one step at a time, do your calculating like normal, but then go back. Where should it have stopped? Let me keep track of that. Where should it have stopped after the next step? Let me keep track of that until you get to your final answer. All right. Let's see. Next up are metric conversions as an example of dimensional analysis. We're going to do a bunch of dimensional analysis in this class, especially when we get to chapter 6 and 8. There's a whole section there. Also a little bit in chapter 11. But it keeps coming back. But it starts here in chapter 2 with the metric system. And so we have 2 conversions we want to do here, both from problem 69, A and C. We want to go from kilograms to grams for the first one, and then milligrams to kilograms. And the way I like to do these to figure out, well, what should I convert with, right? Dimensional analysis is always, you're going to have some given. Here they are in these problems. You're going to multiply it by a fraction or two. This is what we call the conversion factor. The given unit always goes on the bottom, so that will cancel out. The desired unit will always go on top, so that, okay, that's what I end up with. And then you'll plug in the numbers that make these two things equal. Because in math, if we're going to change something in an equation, we're only really allowed to do either the same thing to both sides or multiply by 1. And so that's what we're doing here. We're multiplying by 1, and that'll give us our answer. And so for both of these, we're going to first say, what is the conversion we need to use between the units? And then we'll set it up in this form, and then we'll do the math and get our answer. So for the first one, we're going between kilograms and grams. I always prefer to look at it as saying, let me have one of the larger unit, and then equals how many of the smaller. So I have 1 kilogram, because kilo means 1,000, is equal to 1,000 grams. And so that's my conversion. I'm going to multiply or divide by this somehow once I know where to put things. All right, so now once I have that, let me take my given, 3.55 kilograms. I'll multiply by my fraction. The given unit goes on the bottom. So I was given kilograms. Kilograms goes down there. I want grams. Grams goes up top. And now I plug in my numbers where they go. It's 1 kilogram on the bottom. It's 1,000 grams on the top. And then this tells me, oh, because the 1,000's up top, it's going to be 3.55 times 1,000. The kilograms cancel, and we get 3,550 grams. Okay? If you were asked to do this with sig figs, and you say, oh, well, I only start with 3, I got to end with 3, you would do 3.55 times 10 to the third grams. But that's the thing, kilo means 10 to the third. So that kind of goes together sometimes. All right. The second one here is actually a two-step problem. I've been doing this long enough. I could go between milligrams and kilograms on my own, but a lot of people learning metric, no, we like to go one at a time. So what I would look at here is saying, okay, I happen to know that I can go from milligrams to grams and then to kilograms. That's my plan of attack there. So I know that, oh, there's 1,000 milligrams in 1 gram. But then I also know that, just like I said earlier, there's 1,000 grams in 1 kilograms. And because we're going to do 2 steps, we'll have 2 conversions, we'll have 2 fractions. But again, now that we've got this, let's start with the given and set things up. So 4,598 milligrams. That given unit goes on the bottom, so milligrams on the bottom first. We're going to grams first in our plan of attack. And now we'll use that first conversion. 1 gram is 1,000 milligrams. Right? And then milligrams cancel out. We're good. But that's not our final answer. We got to grams, but we want kilograms. So we come back over here. We say, okay, second step. I have grams now, but I want to get rid of it. So now grams goes on the bottom to cancel out. Kilograms goes up top. And use our second conversion. 1 kilogram is 1,000 grams. Now the grams cancel out. We've got kilograms. And we do the math. We divide by 1,000 once. And then we divide by 1,000 the second time. And that would equal 0.004598 kilograms. Yep, that's right. Or if you want to do scientific, 4.598 times 10, in this case 1, 2, 3 spots, 10 to the negative third kilograms. Right? So I'm hopeful that these examples can help you out with some of the common issues that students have, or at least get some practice and confidence built up in doing these. Please remember, these videos are meant to be examples, just to give you a little hint. They are not replacement teaching for coming to lecture. Always come to lecture. They are not replacement for reading the book. You should always read the book. And they are definitely not replacement for going to the academic center, speaking with our science tutors. They are great people over there. They can really help you out. They've been doing this for a long time. Please see them. See me for office hours, especially at the beginning of the semester. Don't fall behind. Ask questions, get help, and succeed. All right. I hope this sees you well. I will see you next time. Have a good one.